Hi, my name is CJ. This time, let's talk about how photography works. So, let's recap from last week about what we know the basic terms of photography. Photography, as we know it, is running with lights. That is, light that you got photography. This process has to be done through mechanical or digital devices, commonly known as cameras and phones. That anything that gives out the lights is called a light sources. Basically, light sources are categorized as natural lights and artificial lights. And the artificial light can be, again, categorized as non-continuous and continuous lights. Here's a short film that indicates how camera works.
It's all about light. The digital camera. It's revolutionized photography by transforming light into electricity. Everything is there to draw in light, from the camera's buttons, controls, and dials down to the lenses. What the digital camera does with light is what makes it so revolutionary. It turns light into electrical charges that become the image captured on the screen. Light particles, or photons, leave the source, bounce off the subject, and enter the camera through a series of lenses. The photons then follow a designated path on their way from photon to photo. A series of lenses allows the photographer to capture the clearest image possible. This lens diaphragm is what controls the amount of light that the photographer allows in through the camera's opening or aperture. After crossing the diaphragm, the lenses, and entering the aperture, the light bounces off a mirror and heads for the viewfinder. Before it gets there, the light is flipped over as it passes through a prism. That's so the image seen in the viewfinder is right side up. If the photographer likes the image, time to press the shutter button. The mirror lifts and the light rushes in. For a fraction of a second, the light is not heading in the direction of the viewfinder, but for the very heart of the digital camera, the image sensor. The duration of this fraction of a second depends on the shutter. That opens just long enough to expose the sensor to light. Now, to the real heart of this digital revolution, the element that captures the image sensor. A tightly structured grid made up of extremely tiny light sensors. When the photons hit the light sensor, they are absorbed by the semiconductor material it's made of. For each photon absorbed, the light sensor emits an electric particle called an electron. The photon's energy transfers to the electron. That's the electrical charge. The brighter the image, the stronger the electrical charge is. So each electrical charge has a different intensity. A circuit board then converts the different intensities into computer language. They represent millions of tiny colored dots that make up a photo. The pixels. The more pixels in a picture,
well, here goes. Here's how the camera basically works. Okay, and so next slide we are going to talk about subject. So let's talk about the aperture. Aperture is actually the eyes of cameras, and it's about the opening for the lens. So you also control the amount of light to get into the cameras. Okay, the mechanism that controls how much light enters the cameras. It is to look like this. And usually the ring shape opening that made up the middle brace in the lenses that it is to be the mechanism control the light you can tell from the animation here. Actually the opening is indicate the numbers, the F numbers. Okay, it's an aperture ring. But this is kind of older type of lens. You can see that from the ring, but newer lens, you don't have the X-ray anymore, but it indicates in the cameras. You can tell from here the figures of the aperture numbers indicate the smaller on the lens opening, like here. Okay, while the smaller f number indicate the big opening. That's here. Okay, the opening for the lens is from 1.4 to 2.8, 4, 5.6 to 8, and and so on. And remember this: when you see the f number smaller, it means that the lens can be open wider, whereas the f number is bigger, the lens opening is smaller. Okay, here I show you another indication for the lens opening. If from here you can tell from 1.4 to 2.8, 4, 5.6, and 8, F11, F16. And you can tell how much and how little the shade of the opening that lens can become. Okay, remember this: the f number is smaller. That means the lens aperture will be wider and larger, whereas the f number is bigger, the opening will become smaller, and the small opening with the lens. And we let the amount of light to get into the camera's field. Now we cover all the aperture, then we have the shutter speed. Again, shutter speed is to control the amount of light in time length. Okay, and a shutter speed refers to the length of the exposure time. That it is a control like this. That the digital PSM uses the linear design shutter speed and high performance like this. Okay, the faster of shutter speed, it will frozen the action, while the smaller shutter speed will blur the actions. The aperture effects were showing, like I told you guys earlier, the f number is bigger. That means the smaller aperture. That it not only you control the light amount into the lens, but it also will show the aperture reflected DC be clearness, sharpness. Okay, the wider opening, that means the smaller numbers, the f numbers, it would be yellow much more light into the lens, and you got a shorter aperture. There's a field. You can see you emphasize the lens objects and that the background be blurry. Now, the depth of field we're talking about is based on the lens operation, but the focus on the subject at a distance or the subject at that distance are sharply focused. It's not about the distance only, but out of focus. So if the subjects are in the distance, within the distance, that will be focused. If they are not this distance, they are be out of focus. Okay, the zone of acceptable sharpness is referred to as the depth of field, DOF. Increase the DOF, increase the sharpness of the images. The use smaller aperture will increase the DOF. Here we see samples for the aperture and the depth of field effects. Okay, you see the f number is 16. You got everything. I mean, you got more clear distance. Showing where this is f2. Only got this area is in sharpness. So you can tell that smaller aperture, the bigger F numbers will attend the longer clearness in focus, and the bigger opening, the smaller F numbers, you get a shorter depth of field. Here is another the diagram for showing the depth of field. You can tell from the object 1, 2, 3, and 4, and 5. The second one and the third one, the fourth one is within the depth of field zone. That means if you see the number subject of number 2, number 3, and number 4, they are in focus no matter what. Within the distance, within the zone, everything will be sharp, will be in focus, while the object 1 and object 5 will be out of focus. And then you see it's kind of fuzzy from there. So you get your number 2, 3, 4, that's in the so-called depth of field zone. And out of that, that'll be out of focus, whereas number 1 and number 5 objects. Yeah, this is the figures that they're talking about. The figures suggest number 2 and number 4 will be the zone and will be focused on the photographs. Number 1 and 5 outside the zone will be out of focus. Okay. Now, showing another one for the there's a field, we can tell that this number that we say emphasized more than one times. The smaller aperture will give you the smaller aperture numbers will give you wider opening, will give you shallower depth of field. And the bigger F numbers and you got smaller aperture opening, but you yield a longer depth of field. So this is how we can use the depth of field to emphasize the story. For instance, I'm taking a picture here. I want to emphasize these flowers. And here I will emphasize, and everything out of that will be out of focus. But if I want to emphasize the mountains is far away, and I will put my focus point here, but my foreground middle point will be kind of fuzzy. If I want to emphasize everything in my sights, and I will put that infinity from really close to me object to really far away object from me. Okay, now I'm showing a couple samples and how do we use the focus points. The next one is the distance, but my focus point is far away the buildings. My foreground will be the plants in the street. That means, I'm looking for the longer distance of the shot. In here, we are talking about the focus points from the nearest the street to the farthest the building. That means I'm looking for the street scenes in Kuala or in Malaysia. That everything was in focus. That's pretty much I'm just showing this picture here. Okay, let me show you another example from the internet. Okay, this picture was taken by two larger, rather larger pictures, which is in why the pieces are sharp in focus, but the other elements are in blur. You can tell that pretty much in the here because these two kids are my emphasized points of the picture. The other, they are playing on the street. That's really nice. The environment city. It's nice, but the key point is those two kids. Different from the previous pictures, this one is taken at the 16, which is a small aperture. You can tell that picture is showing here. It will be focusing the foreground to the nearest foreground. Yeah, you can see everything is in focus there. And even though my focus on this, the old street, the lake, but if it's close to me at the farthest point, and even the sunset is in focus. That shows that longest there's a fail was showing on this smaller aperture. All right, but 15 minutes is up. The examples of the data when I use, you can find out the difference in here. And on the probably around that, I did borrow the picture that cube